Today we're going to talk about Edison Motors Truck and the advantages of a diesel electric.
Yeah, so the Edison Motors Truck is diesel electric. It's a fully electric truck, as in if you were to remove the diesel generator, it would still exist as an electric truck. It's a range extender essentially. So how this truck works is being fully electric, it drives and operates off the battery, but when the battery gets low, the diesel acts essentially as a level 4 fast charger to recharge those batteries. You can drive the truck for about 2 hours to 3 hours off that battery, and the diesel generator recharges while you're driving down the road. In about 30 to 40 minutes will fully recharge those batteries back up.
It's an electric truck with an onboard generator, onboard charging system.
That's essentially right. So it takes its inspiration from a freight train, which have been diesel electric, and they use large capacitor banks. We use large lithium-ion battery banks. And my belief with the way electrification is going is that if electric is the future, battery technology needs to get more dense, weigh less, and become more compact with better charging infrastructure. And to get us to that point, the diesel electric with that generator on board is the next logical bridge gap in that solution.
What would some of the advantages be to have a diesel electric logging truck?
Yeah, some of the main advantages to these diesel electric trucks are the power and the torque. The torque curve on an electric motor is flat. Where you normally get your torque on a truck, it's up, you hit a peak RPM, and then it falls back down again. Diesel electric, you get that instant RPM, that instant torque right from zero. Full torque right from zero and high torque. So with this truck, the power output is it has 3 electric drive motors, each with 250 kilowatt hours, 750 kilowatt drive motors, which gives you over 1,000 horsepower, but the torque is 110,000 foot-pounds of torque. If you compare that to a normal Cummins X15 550, it puts out 1,800 foot-pounds of torque from the motor, goes through its gear reduction, which means in first gear at max torque, it gives you 60 to 70,000 foot-pounds of RPM, assuming you're running like 433 rear ends. That would give you around that 70,000. So that's a low geared rear end, and we are still almost double what first gear is in torque, and that torque is going to be smooth and linear across the entire power output. Apart from just the torque of the electric motor, it's the fuel savings. You're using that battery as a peak load demand. A truck takes a ton of power to really get it off the line and get it moving. You got 140,000 pounds on a Super B in BC. To get that up and moving, it takes a ton of power, but once you're up there, you don't need the power. You back off the throttle, you just maintain your momentum instead of building that initial inertia. So that battery gives you that full 1,000 horsepower shove off, and then once you're up to speed, it doesn't do a lot. Plus, as you're going downhill, AC motors, the motor actually acts as a generator. It puts a load onto your drive axles and sends the power to recharge the battery. So when you're coming down the hill, you're recharging the power back in the battery, it's building up, and it gives you the peak load demand to climb up the other side. Same as if you're slowing down to stop at a light. It's rebuilding that power back up. It stores that power and it reuses you to launch off the line, which really allows you to put in a small generator to maintain its peak load, which essentially what we've done is we've taken a 15-liter Cummins, we've reduced it down to a 9-liter engine. Basically, instead of having a 550 horsepower motor, we have a 400 horsepower motor. It puts out 350 kilowatts. The Super B going down the highway uses an average of 200 kilowatts. That's what it requires to keep that momentum moving. So an extra 150 goes back to recharge those batteries. You get about 2 hours of drive time off the batteries. It recharges those batteries in about 30, 40 minutes. We have 250 kilowatt hour battery pack on board as opposed to running a full-size megawatt battery like some of the other commercial trucks do.
So the generator is running off diesel, but it's not running near the amount of time as your motor would be, and it is a smaller generator. How would that result or reflect in your actual fuel savings? I guess it would be dependent on terrain and things like that, but what do you kind of project?
For fuel savings, that is one of the hardest things to predict because we are building heavy vocational trucks for the logging, garbage, heavy haul, oil field, vac trucks, those kind of things that it's not easy to calculate. If it was a highway tractor, we could just enter the math and see what it does, but highway OTR work, pulling a dry van, is the worst application for this.
Apart from like a dry van going down the highway, how would you estimate the projected fuel savings?
Okay, so the best way to say that is that the harder you work this truck, the better it's going to do. The more down and uphill you have, the more regenerative braking, the more stop and go, the better fuel mileage you're going to get. The harder you work it, the more you pull, the better you are. So to explain it this way is that a C9 generator uses about 50 liters of fuel per hour, which means you're going to use 50 liters of fuel to recharge those batteries, and you're going to get a couple hours of driving. Now that's pulling Super B weight, so instead of looking at 60 liters per hour fuel consumption, you're looking at 25 liters per hour fuel consumption. On a logging truck, like where we've built our prototype and we've done the testing uphill, downhill, with that sort of hill, we're looking at about a 75 to 80% reduction of fuel mileage. As you're coming down the hill, you're recharging that battery so you can go back up the other side. You're coming down on a logging truck, you're down the mountain loaded, you're going back up empty. On a real ideal application, you might never have to fire that generator up. You could have 100% fuel reduction. So I can't give a mile per gallon savings, but if we were to look at the application, you can clearly see how this makes sense to save money.
So you'd have the benefits of the electric being the torque and the power that are nowadays unheard of in a truck, but to estimate the fuel savings is really depending on the application.
Yeah, and a gravel truck, a garbage truck in a city, stop and go between all the lights, amazing. You have that smooth power curve, and one of the advantages is that generator is running at peak RPM. One of the problems is due to the limited RPM range of a diesel motor, 500 to 2000 RPM traditionally in a truck, you're limited to a 1500 RPM range. These electric motors go up to 20,000 RPM, but the generator producing power can actually produce power at 1750 RPM. It gets there and it stays there. Why that makes a big difference is the way that the internal combustion works on a diesel. What happens is your turbo is what builds your fuel-air ratio. The turbo relies on the exhaust gas coming out of the manifold. It spins a big fan that sucks air in, which that air being sucked in and forced in with the turbo from the exhaust gas is what gives you a good fuel-air ratio. What happens is when you shift gears, you let off the throttle, the truck shifts a gear, that exhaust spools down because you're not working the motor hard. It then needs to pump fuel into the block to create those exhaust gas to suck the air in, which means you're getting really poor fuel-air ratio mixture at that start. You're burning inefficiently just to get going to build your peak RPM, and then you shift gears. And that can be up to 18 gears in a standard truck transmission that every time you shift the gear, you lose your turbo boost, you go out of your peak RPM range, and you got to work to get back there. With the generator, you're staying right at that peak perfect RPM that you want to run at, and you're letting that electric motor and that battery give you the boost you need instead of shifting.
That sounds like you're gonna also, it's gonna be a lot easier on the generator. It's not gonna be have to work as hard, I guess. It's running at a higher RPM, but it's not going to be working hard, pulling that load with fluctuating up and down, which I know can wear out components really.
Diesel motors love getting into their peak comfy RPM and staying there. They're not throttling down, they're not adjusting, they're not generators, especially the old mechanical ones. There is legends of generators, 3406 cats going to over 100,000 hours without a rebuild. The average generator, you're looking at about 40 to 50,000 hours before you need to rebuild that block. Now, if you were to look at a truck being used shifting gears, you're looking at 20,000 to 25,000 hours before a rebuild. So therefore, this making it run as a generator is doubling your service life of that diesel motor in the truck.
So you might be saving money on service and mechanical breakdowns or whatnot that happen, rebuilds. But I know that driving truck, you're often paid by weight, and electric and batteries weigh a lot. So you must be losing there. What about weight for Edison Motors Truck?
So batteries weigh a lot. So if you look at something like another conventional 100% electric truck, they use a megawatt almost of batteries. That megawatt of batteries pushes the weight of the truck about 2,000-3,000 pounds higher just due to the massive weight of it. So what we've done is, because our batteries are really there for that peak load demand and to let the truck run for a few hours off the batteries, they're much smaller. We're 250 kilowatt hours as opposed to 1,000 kilowatt hours, quarter of the size. What we've also done is gone from a 15-liter diesel down to a 9-liter diesel. So we've massively reduced the weight of the diesel motor. When it all said and done on our first prototype truck, before we started, because it was a retrofit of a 1962 needle nose Kenworth, when we started the build, the truck weighed 9,000 kgs. When we finished our hybrid upgrade, we put it onto the scales, it was 8,800. We lost 200 kgs, 450 pounds of weight reduction by going diesel electric. And on top of that, the government in BC gives you a weight allowance because it's classified as electric. It can run 100% off the electric without the diesel. If it was a hybrid, it would need the diesel to work with it. But the diesel can be shut off. We could remove the diesel, put in larger batteries, and it wouldn't make a difference to how the truck performs to make it 100% electric. So because it's electric, we get an extra 1,500 kgs in weight allowance on those drive axles, which means for your payload, they did that to accommodate the weight of the extra electric trucks. Ours, being lighter, for that payload, you get that extra 3,000 pounds. So with a little bit of weight reduction, I mean, the tri-drive setup's going to be a little bit heavier, and in the production version, we've increased the truck by about 500 to 1,000 pounds. We're getting on par, but in total, you should be able to pack in a few thousand pounds more weight than you can with a normal diesel.
Your generator is going to last longer.
Yes.
You can actually, in theory, you're going to be able to pack more weight, make more money. But then I don't know how to work on electric vehicles. What about the serviceability of that?
So this is one of the things that, because we built all these classic trucks and we really started as a trucking company with mechanics that work on our trucks, we needed to make sure that if we were going to have a truck, number one, we had to be able to build it. And a lot of our mechanics are apprentice. They're not even Red Seals. We have one Red Seal mechanic comes by to check on things. The main guys in their shop they have that owner-operator background. They're third, fourth year apprentices going in for the Red Seal. But we did this to make sure that the truck could be worked on by people that aren't technicians. Other than Eric, who's our chief technology officer, and a few of the electrical engineers that have come on board to advise on things, the people building this truck in the shop are diesel mechanics. We specifically chose parts. Like, we partnered with CBS, Fleet Brake, and these companies to select the best parts, those parts that they always have on the shelf. That's what was used to build these trucks. The electrical wiring harnesses are actually relatively simple. We've reduced the driveline components, but your brake pots are your standard Type 30 brake pot, which means you have your standard slack adjusters, the airline, the coupling, the brake fittings. None of these parts are Edison Motors specific parts. They are all parts you can get off the shelf.
Now, what about the battery life?
Yeah, that's one of the big concerns about people with EVs, is that a megawatt of batteries is hundreds of thousands of dollars. Our battery cost, I'll just straight up tell you, is about $30,000. That's $35,000 is what you get for that 250 lithium-ion batteries. So it's much cheaper when it comes time to service it. You're looking at on par with doing an engine rebuild, but you don't have to do it as much on ours. Batteries degrade over time. That's not something you can avoid. But we have a diesel generator powering those batteries. So if you could get 2 hours of driving off the batteries when they're new. In 5 years, they lose a lot of their charge. Let's say it's an overly aggressive example, but let's say it uses 50% capacity. It loses 50% of its capacity due to being used a heavy usage. You should be looking at about 70% reduction in 5 years, but whatever, let's say 50%. Now on a normal truck, the big issue with the batteries is that it lowers your range. So on a normal EV, you would lose your range. So if a fully electric semi is rated to do 500 miles on a single charge, 5 years, if it lost 50% of its charge, can only do 250 miles. You can see how that would be frustrating, as it requires a lot more stopping. But we have that diesel generator. So if our capacity goes down from 250 to 125, all it means is that that generator needs to come on more frequently to recharge it. So instead of running it for half an hour and then driving for 2 hours, you now need to run it for 15 minutes and you drive it for an hour. It doesn't affect your range of your truck the way it would in a normal one. It doesn't require extra stopping, which means you can push the lifespan of that battery back to years and years. Eventually, it might get to the point where you're like, oh, this is annoying. The generator needs to run relatively more constantly. That could be a thing, but you're looking at 10, 15 years out of that $35,000 battery, as opposed to looking at 5 years out of $150,000 battery. So you can see that cost savings. For $35,000, you get 10 to 15 years. For $150,000, you get 5 to 7 years before it's really frustrating to the point where you're like, I can't make it through the day without stopping multiple times. And the other advantage is, because you're recharging it, you can set that generator so that it keeps those batteries above 50%. You're not cycling down to that bottom end in your battery life range. Where you really do your batteries is when you drain them all the way down. If you set that generator to turn on when it hits 50% and build it back up, you're not working its battery constantly through its whole thing, degrading the cells. You're keeping it nice and topped up, which is much healthier for the battery and going to give you a longer time.
What about the reliability of electric motors compared to that of mechanical motors?
Electric motors are actually much more reliable. A mechanical motor, a mechanical transmission, you have, just check out the image of a mechanical transmission. Have a look at this thing. You'll see there's counter shafts and main shafts and gears and shift forks moving all these things together. Electrical motors are actually incredibly simple. All they are is a magnet spinning inside some copper wire. There's not a lot of moving parts. They're simple. They last forever. You can find electrical motors that are still in operation from the early 1900s. They work. They work well, they're reliable, they're easy to service, you can rebuild them easily. They are a pure, simple service thing. As long as the company makes it easy to work on, designs it with serviceability in mind, you can get incredible serviceability and lifespan out of these electric motors. Have a look at the mill in town. The sawmill in Merritt here uses Laternos. The one Laterno they use every day to unload logging trucks was made in 1967, and it is diesel electric. A diesel generator moving electric motors, electric winches, electric rack and pinion steering, electric hub motors, and this thing still unloads logging trucks every day since 1967. That's how long this log loader has been in service for. If you compare that to a normal mill loader where you get 5-10 years of service, they're going on 50 years still unloading hundreds of logging trucks per day just as efficiently, because that's how reliable these electric motors are.
It's more reliable, less maintenance, higher gross, better fuel mileage. Overall, this sounds like a pretty...
More power.
More power. It's a win-win.
Yeah, this is one of those solutions that freight trains have been diesel electric since the 1930s, and they can move millions of pounds of freight. Why hasn't this been done in trucks before? Like, this is the obvious solution, the diesel electric trucks. The technology is there now to make easy, simple to maintain, build, and construct diesel electric trucks. Why hasn't this been done? This is the obvious bridge gap between pure diesel mechanical and full electric. Battery technology isn't there yet. That megawatt battery still weighs 20,000 pounds. It needs to get more energy dense, quicker to charge. We need more charging infrastructure. We don't need charging infrastructure for this. Charging infrastructure is going to be 20, 30 years into the future, as every single truck parked at a truck stop needs to plug in for 10 hours to charge these trucks. 10 hours you need to be plugged in to charge a megawatt battery. That is insane. They're saying 5 hours, but it depends on the level of power infrastructure. That's another deal. The point is you need charging infrastructure at every truck stop, and that means that your average truck stop is going to be requiring more capacity and energy than small cities. So truck stops in the States could use more power in just one truck stop than the entire city of Kamloops. With the diesel electric, you don't need that charging infrastructure. It's going to take years for us, decades for us to upgrade that grid infrastructure to supply the electric. So if we can reduce fuel consumption, we can burn that fuel cleaner, and we can get those electric motors, the electric technicians, the truck technicians. This is the way to bridge the gap between just diesel and diesel electric. It's all the benefits of the range and simplicity and the ability to fuel up of diesel with the advantage of the fuel savings, the power, the efficiency of electric. This is the, hands down, in my opinion, the best way to go.
It is the appropriate first step in the right direction.
Yes.